In this video, we'll be talking about linear systems in two variables. This is the first part, focusing on types of solutions and solving with substitution. The objectives of this lesson is, given a linear system, you're going to be able to solve it using substitution or elimination. This is both 2 and 3 variables. And given a system of equations, you're going to be able to determine if the solution is unique, dependent, or inconsistent, and justify why. So to start us off here, we're going to solve a system like this. So the system is the two linear equations, which you notice that both of these are lines. So they are linear equations. That is what we are going to be focusing on in this chapter, is linear equations. Two equations of 2, 3 equations, both of which, or all 3 of them, are lines, or linear in that all of the terms are degreed 1. So like you have an x, y, and later on we're going to have an x, y, and a z. You're not going to see anything like z squared or z cubed or anything like that. So these are linear equations. And so for these, the most common approach is using this thing called substitution, where if you can look at these equations and go like, well, I can manipulate one, so it's like, for instance, y equals, like the slope, the standard slope-intercept form of the line. Once you have the slope-intercept form, you get to plug that into the other equation. So that's what we're going to do here. So we're going to use substitution. And so in this case here, I'm going to pick this second equation and solve it for y. So I'm going to solve the second equation for y. There's no reason you can solve the first one for y, you can solve the second one for x, the first one for x. Honestly, it doesn't matter. I'm just choosing that one, honestly, because it's a little bit more tricky out of all of those options. Just to show you, there's no particular reason. So then taking that equation, we have an x minus y is equal to 4. Adding y to both sides, we get y plus 4 is equal to x. So then y is equal to x minus 4. So now that we have what y is equal to x minus 4, we can then take a look at this first equation. So we have the first equation as x plus y is equal to 8. So x plus whatever y is has to equal 8. But we know that y is equal to x minus 4. So we can substitute that in. So here I'm going to have x plus, and then I'm going to substitute this y for the expression x minus 4, because y here is in fact equal to x minus 4. So here, I get an x minus 4 is equal to 8. And so you can kind of see here, as I change the color, that the x plus x minus 4 is equal to 8. We've reduced it from 2 variables, an x and a y, down to 1 variable. That's what the point of substitution is. Substitution, your goal is to reduce the number of variables that you have. Now, simplifying and solving this, we get 2x minus 4 is equal to 8. 2x is equal to 12. So x is equal to 6. So we got our first value here. We got that x is equal to 6. But we also know that y is equal to x minus 4. So then as y is equal to x minus 4, and you know x is equal to 6, then we get y is equal to 6 minus 4. Again, I use parentheses when I'm plugging things in. Helps me keep track of everything. So now simplifying this, you get y is equal to 2. So then our solution is x is equal to 6 and y is equal to 2, or as an ordered pair, 6, 2. Let's talk a little bit about the geometry of really what's going on here. So when we solved this equation using substitution, we found that the solution was 6, 2. So what that's saying is that as an ordered pair, the x value is 6 and the y value is 2. So when we graph these, and I'm going to do the first one in green and then the second one in orange. And so graphing these two equations, we see that the first one has an x-intercept of 8. The second one has a y-intercept of 8. And now we're going to connect those. And then the second equation here, the x minus y is equal to 4, has an x-intercept of 4 and a y-intercept of negative 4. So now connecting those. So really what we are saying here is that this intercept of these two lines is going to be that 0.6 comma 2. So I was a little close there, so looking at this is our 0.6 comma 2, which given up to my drawing abilities here would be that point of intersection. So when we solve this system, it has this unique solution. So it has a unique solution, and it is the point of intersection of these two lines. So that leads us to a question, what other types of solutions do we get? And that really comes from the geometry of the lines involved. So the types of solutions that we can have to a system of linear equations in two variables, we'll discuss the three variable case later, is that there can be a total of three essentially classes, the classes that people do. And so we have a unique solution. And in this case here, we have two lines, one coming like this and another one like this. And so you're going to get that unique point of intersection between the two as a unique solution. And so the key feature here is that there are two lines with different slopes. That is the important feature. So the different slopes will give us that point of intersection. You can see that the orange one has a negative slope and the green one has a positive slope. But even if they're both positive, you will still see a point of intersection. The second one is no solutions. So the no solution can be a case like this, where you have a line like that in green and a line like this in orange. And so the feature here is that you have two lines with the same slope, but different intercept. So the y-intercepts here are different, but they have the same slope. These are parallel lines. So they're parallel lines with different y-intercepts. That will give you no solutions. And then the last one is infinitely many solutions. And so how do you get this one? Well, if I give you a line like this and another line just right on top of it, these are the same line. So this is the same line. And so often in this case here, they'll be written slightly different. So you can think about this like, let's see, like x minus y is equal to 4, or y is equal to x minus 4. So if I gave you both of those equations, those would define the same line, but are written differently. So like that's a system of equations with infinitely many solutions because both lines are the same. So these are the three classes of solution types to a system of linear equations in two variables.